Random walks are one of my favorite things to study in Math 9, and they're something that we've talked about every quarter I've taught the class. And the reason I like them so much is because I know really well how to study them using MATLAB and Mathematica, but I don't have any idea how to study them using pencil and paper. So they're an example of how technology really helps with this certain type of mathematical object. So there are two types of random walks, one using for loops and one using while loops. Let me start with the for loop one. So there are a few things that both types have in common. Both involve starting at a number 0 and then adding +1 or -1 for a certain amount of time. And the big difference is that the for loops random walk, that we go for a fixed number of steps, whereas the while loop random walk, there we go until we hit a certain distance from the origin. So today we're going to start with the for loop random walk. So let me call it walk 1. Input is going to be n. Output is going to be a vector v. And idea behind it is we're going to use a for loop. We're going to start at 0 and add +1 or -1, okay, randomly for n total times. So at the end of this, v is going to be a length n+1 vector. So probably the hardest part of this is how do you randomly choose 1 or -1, but we already talked about that. The slickest way to do it, if not the most adaptable way, is to say s, how about first step, equals -1 to the rand I 2. Okay, so this is either -1 to the 1 or -1 to the 2. So total it's either -1 or +1, chosen with equal probabilities. And how do I do it? Well, I start with v equals the vector that just contains 0. So this is a little different from how we usually initialize our vectors. Usually we initialize our vectors to be empty, like with nothing inside the brackets. But here I'm starting with a number inside the brackets. I'm starting with 0. And then I say for I equals 1 up to n. And then what do? I want to add this random choice of 1 or -1 to whatever the final value was in v. Okay, so if we're on square -8, then I want to either step forward to square -7 or step backwards to square -9. So how do we do that? We do v equals, and then what should go here? Well, it's not going to be v, it's going to be v end, so whatever the most recent position was, and then we either add 1 or -1 to that. And then that's all we have to do. So let me save it as walk 1. And let's take a look at what this looks like. So say I do walk 1, 5. Okay, so step forward, step backwards, step forwards. Okay, and we took 5 total steps. So here's the first step, here's the second step. Total, it was length 6. Okay, let's try another one. So you can see that it's always something different. Here's another one where it just oscillates back and forth. And so notice that they're ending at different points. When we talk about the while loop version of random walks, there it's going to always end at either a +n or a -n. So that's the big difference. It'll be different lengths, unlike these, which are all the same length if I do the same input. So as an example of a longer one, let's say walk 1, 100. Okay, so even though it took 100 steps, it ended at 2. So ended really close to 0. Here's another one, ended at -8. So some basic questions we can ask are, where do you end the random walk with n steps? Or another basic question we could ask is, what's the furthest we ever get from the origin? So in this case, it looks like maybe -15 is the furthest we ever get from the origin. Let me show you a common mistake that can be made with random walks. A common mistake would be, instead of having this -1 to the rand I2, a common mistake would be to have just add rand I between -1 and 1. Okay, let's see how this would look different. So I've saved it, go back to the screen. So here, notice that it didn't go anywhere, it just stayed at the same place. Okay, here's another example where it didn't go anywhere, it just stayed at the same place. So the problem is that here I'm adding -1 or 0 or 1, whereas I only want to add -1 or 1. So that's why we have to do this more complicated way. I have to do -1 raised to the rand I2. So I've saved it. Let's look at walk 5 now. And here it's always going either forwards or backwards, one step.